Hello everyone, this is a quick and basic demo of tracking an AR marker using a system of two webcams. So on the left side of the screen, you have a top-down 2D view of what the cameras are seeing. I'll try to get a 3D view working for the final demo. In the middle, this is not a webcam I'm using for tracking. This is just to show you what's going on. And on the right side of the screen, you see numbers printing out. So these are kind of the difference between the positions of the marker as seen by the two cameras. I'll explain this a little bit more later, but for the physical setup, I have one webcam here on the tripod looking down, and another one over here on the opposite side, and this region down here is it's our tracking region basically. And I'll put this camera over here, and I'll run some demos. So as I start to move around the marker, you can see the dot on the left top-down view is moving with the marker. And because the numbers are still printing out, I know that both cameras are seeing the marker, and the location being displayed is an average between the positions detected by each of the webcams. And what I want to do is start tilting over kind of the board, and you can see that the number on the right has stopped printing. This is because the camera on the right hand side cannot see the marker anymore because I've tilted over towards me. But you can see the dot is still moving with the marker. That's because for AR markers, we actually only need one camera to determine the position and orientation of the marker. I chose this to kind of give me the benefit of being able to test with just two cameras. The same would apply if you want to do object detection with more cameras instead. In that case, you will just have more than two cameras, and you need two cameras to see the object at once to be able to triangulate the location of the object. But the idea of kind of averaging inputs from multiple webcams and kind of having this robust system of multiple webcams and not all of them have to see the object at the same time is what I'm going for with this setup. And now, as you've seen, I've tilted the board towards the other side, and the number has stopped printing out because now only the other camera can see the marker. But the dot is still moving around as I move the marker around. And if I just kind of start going crazy with the board, tilt it back and forth, you see that the system will pick up when both cameras can see it. You can see the numbers printing out, but there are no like weird jumps or stutters between transitioning from just the left camera to both cameras to just the right camera, because everything is of course in the same coordinate system. So it will kind of just automatically transition between different inputs, and it will maintain smooth and consistent tracking throughout. And if you pay closer attention to the numbers on the right, you can see it's around 0.00510-ish. So that's in meters. So that's about 1 to 1.5 centimeters, which is about half an inch. And that's how much difference there is between each of the camera's estimation of where the marker is. So for a not so well calibrated camera array, I think that's a pretty accurate result. And there are a few other things I want to show just really quickly. One thing is kind of the improved UI. I've already shown it during the midterm demo, but there has been some upgrades. So one thing is this kind of 3D viewport. Was talking about how I want to show a 3D view of the calibrated scene with the targets moving in real time, and this is kind of where I'm at right now. I have this 3D viewport, and you can see kind of that's one of the cameras being visualized. And after calibrating, the camera will move into their real-world positions, and I'm hoping to show where the markers or the tracked object is at in real time here as well. And here for the calibration process, mostly the same. You configure your target parameters on the right, and here I've just added some displays for the parameters once you have finished your calibration process, so you can debug your parameters much easier. And the other thing I wanted to show is kind of just a quick run through of some visualizations of how things work and kind of what I'm doing. Here is kind of what the process of camera calibration looks like. So this is kind of visualizing what the cameras are seeing as far as the calibration target goes. And this is kind of undistorted, calibrated frames from individual cameras. You can see it's not super obvious at this scale, but you can see that there's kind of like a black gap below. That's because the image has been warped to take out the optical distortions. And what you can see here is visualizing kind of the positions and orientations of the two cameras, similar to the UI, but the UI is a little broken right now. But here you can see the two cameras, their position, where they're pointing at, and these two dots are kind of where I have kind of a simple frame in there, and this is kind of showing the same idea, right? That how the two cameras see the same target, and the two dots are representing what each camera is seeing. And here you can see the distance between cameras. I've measured this with a tape measure, very accurate. And this is kind of just the distance between the two markers that's seen by the two different cameras. Same thing as the numbers that we're printing out on the right-hand side of the screen during the demo. And another quick thing here is this is just kind of showing you how the camera is picking up the marker in a frame. This is what the camera on the right-hand side is seeing. And here you can see kind of the camera is picking up what the marker is, and it's doing a pulse estimation on the marker. And the green dot in the middle is actually the estimated pulse being reprojected onto the image plane through the camera matrix. And that's pretty much all I have for this demo. Thanks, guys.